Right, this lesson, we are going to be finding higher order derivatives again like we did in the last lesson, but these are going to be found through implicit differentiation. So we're still in topic 3.6, and we're going to be finding the second derivative implicitly. Okay, so let's just look at example 1. We're going to find the second derivative. And that's just one of the notations we could use. All right, our first equation is x squared plus 4y squared equals 1. All right, so just like with the explicit differentiation, we want to find the first derivative first. So we're finding dy over dx. So we're going to use the power rule. And then when our variable is y, we'll still use the power rule, but also the chain rule. So when the variable is an x, we're going to have to multiply by the derivative of y, which is dy over dx. I didn't take one away, sorry. All right, and then just like before, we're going to solve this for dy over dx by moving over the 2x dividing by 8y, and then simplifying. All right. So that is review. Oh, sorry. All right. So now we want to find the derivative of the derivative. So on this, we're going to have to use the quotient rule. All right. So we have low d high minus high d low over low squared. All right, then we'll clean it up a little bit. Now we're not quite finished. What we're going to do now is take what dy over dx is, which is this, and replace it. This is like substitution. It is substitution. So we'll take negative x over 4y, and we're going to plug it in for dy over dx. Then I would want to go ahead and multiply, do some multiplication. Alright, so when I'm multiplying 4x by something that's over 4y, my 4's are going to cancel out. Alright, then positive times negative is negative. X times negative x will have the x squared over y. Now, we all know we don't like to leave a fraction inside of a fraction, so I'm going to multiply by the denominator of the little fraction to eliminate the little fractions. So that's multiplying by y. And you would want to make sure that you distribute that on the numerator. So when you multiply it by the first, do that. Then we multiply this one, it cancels out the y. And then on the denominator, we're going to get 16y cubed. All right. Sometimes at this point you're finished. Sometimes you're not. So I'm going to do something and then zoom out. Hopefully you'll be able to see once I zoom out. I'm going to factor a negative out of the numerator and then also kind of rearrange it so the x is first and the y is second. Oh, I put my square in the wrong place. Okay. Oh, okay. Well, you can see that. All right, so if you look at that and you look at the whole problem, do you see something in the answer that's also somewhere else in the problem? So this x squared plus 4x is the original problem, and that is just equal to 1. So what we can do now is make a note that this is the original problem. And I know that x squared plus 4y squared is just equal to 1. So I can do another substitution where I substitute 1 in for that. All right? And then this is my second derivative. Now, like I said, not every problem requires that last step. So it's just something you kind of check for at the end. Okay, so let's look at another one. So for B, we have x squared plus xy equals 5. And we are going to start off by finding the first derivative implicitly. So the derivative of x squared is, of course, is just 2x. And then when I find the derivative of xy, I'm going to have to use the product rule. All right, so I'll leave x alone, multiply by the derivative of y, plus leave y alone, multiply by the derivative of x, and then equals the derivative of 5 is 0. All right. So let's do what we need to do to solve this for dy over dx. Okay, so I have my first derivative. So we're going to, again, use the quotient rule to find the second derivative. All right, so we have low d high. Minus high d low over low squared. All right, so I'm going to do a little distributing. Alright, and then I noticed something. I noticed that in the numerator I have negative 2x plus 2x. So those are going to cancel out and become 0. And then I'm also going to go ahead and plug in my dy over dx. Okay, so that was negative 2x minus y over x. And I just got that from this right here. works out very nicely because those x's are going to cancel out, become 1 or -1 basically, and then I would make sure I would distribute that negative. Right, and then my second derivative should be 2x plus 2y over x squared. Okay, so I'm going to zoom out again so I can look at the original problem. All right, so my original problem was x squared plus xy equals 5, and that doesn't match up with my any part of my second derivative really. So we're done. That is the second derivative. All right, we're going to do one more. For C, we have 2x cubed minus 3y squared equals 0. All right, so I'll go ahead and do the power rule and the chain rule. And then solve this for dy over dx. Okay, that's my first derivative. My second derivative, I'm going to do the quotient rule. Okay, and then I will multiply. I'm going to go ahead and put in dy over dx, which was x squared over y. Okay, and then I will multiply that. This time, nothing is going to cancel, so I'll multiply x squared times x squared. Okay, now I am to the point where I want to get rid of this y because I don't want a fraction inside the fraction. So I will multiply by y on the numerator and denominator. Oh, let's double check, sorry, our original problem. Okay, so 2x cubed minus 3y squared is not going to plug in anywhere, so we're good. This is the answer. Okay. So your assignment is on page 146 to 147, 45, 46, 50, and 68.